You guys, before I'm going to take any derivatives, I know for a fact something's not going to be differentiable if it's not even continuous. So if I got some piecewise, what I'm going to check first is to make sure that thing connects up. I'm going to make sure it's continuous. In order to make sure it's continuous, I need to check that the limit value equals the function value where it connects up. Because this is a line. This is a continuous function. This is a polynomial. A quadratic. This is a continuous function. You just need to check the connection point. What is f of 0, and how can you solve for f of 0 in this case, Michelle? Into which one? Not both. F of 0 is a specific one. Yeah, this is f of 0 because this is where the point is. And what does it equal? Great. Now, if you wanted to make sure the limit exists, that's where you got to plug it into both. You check the limit as x approaches 0 from the left of this function. What does it equal? The limit as x approaches 0 from the left. Plug in 0 into the left function, and what do you get? 3. The limit as x approaches 0 from the right. So what does that mean about the limit at 0? The limit exists and it's equal to that value. And it also just happens to be equal to the function value. What does it mean when the limit value equals the function value, Rafi? It's continuous, okay? So check that first, because if it's not continuous, don't even bother taking it. You already know it's not differentiable there. Does that make sense? So check that first. It's a good kind of like, checkaroo. All right, cool. So I want to find my critical points, my extreme values. So what do I need to do in order to do that, Katie?
Find where the derivative is 0.
Or? Okay. So what's the derivative of the top function?
-1.
Okay, so this derivative is -1. And then this derivative is minus 2x whenever x is greater than or equal to 0. So that's overall. Okay? Plus 2, I said. I'm going to clean out those ears. All right, here we go. Okay, when does that top function ever have a derivative equal to 0 or undefined? Never. It's a line. It just goes, it's a constant rate of change. What about the bottom one? When does that thing ever equal 0 or undefined? Eve?
Sorry?
When does this derivative ever equal 0? And how can you solve for it? This thing's never equal to 0 because it's just -1. But when does this thing equal to 0? And how can you solve for that? Set x equal to 0? How can you solve for when this thing equals 0? Just set it equal to 0 and then solve. Do one at a time. Do the calculus, then do the algebra. You know what I'm saying? Set up the algebraic equation. You set this equal to 0 and then solve for x. X equals 1. Okay? That is where, for this function, the only place where the derivative will equal 0. And it's always defined, right? Because it's just a polynomial. Okay. If it's a piecewise, Eric, you do have to check one other thing. And that's where it connects up. How do you check the derivative at a connection point in a piecewise function? What's that? Which point? This point, the 1?
No, where the piecewise connects.
Yes. Plug in the x connection point into the derivative values. What does that tell you? What's our goal of that? What are we checking? Yes, check. Make sure that the derivative from the left equals the derivative from the right. If the derivative from the left equals the derivative from the right, then that's the derivative value at that point. Marco, you with me? Okay, so at 0, what's the derivative from the left? At 0, it's always -1. At 0, what's the derivative from the right? What does that mean about the derivative value at x equals 0? Yeah. Why? According to our graph, what do we see there? Yeah, it's a corner. Yeah. It just kind of goes bum. Yes? So two places we have that are possible mins and maxes. These are the points that determine our critical points. So our critical points are x equals 0 and x equals 1. At x equals 0, the derivative is undefined. At x equals 1, the derivative equals 0. What's the y value at 0? What's the y value at 0, Lauren? How did you get this number? On this function, I want to know what the y value is at x. There's nothing to hit. At x equals 0. What do we need to do? Where do we plug in the 0? Which one? This is the original. Which one? Why the second one? Yeah, because that's where it exists. That's where we check. Yeah. And what do you get? Do you agree with that? Yeah, you plug a 0 into here, you get 3 plus 0 plus 0. Okay? So at 0, the y value is 3. What's the y value at 1? How do I do that, Chris?
You plug it into the second equation.
Why the second equation?
Because if it's x is greater than or equal to 0.
We're following this rule. And what do you get if you plug a 1 into the second equation? Yeah, 3 plus 2 minus 1 is 4. Now again, without a graph and without like 2 sections later, I would just kind of take a look at the graph to see which one's the min or max. We're going to learn a technique that'll like show you how to determine that. But for now, we don't know them yet. So, is this a min or a max at x equals 0? According to your graph. This is a min. Is it the absolute min? Is it the lowest? No. What's this? What's at x equals 1? What do we get? A max. We got a max value. Is it the absolute biggest value this function will give you? No. They're just little locals. Okay? It seemed like we liked that one, yes? Did you like it? No, 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 no. You love it. Alright. So let's do this. I want to know, since we're having fun now, I want to know our critical points for the function sine x over x on the open interval.